Okay, pre-calc students, we're still working on the Unit 9 review. We're now on page 3. So to explain in your own words the meaning of each of the following, you definitely need to first try to put this in your own words. But if you're confused about what we're asking for, I'm just asking you to tell me what it says. So it's saying, literally, the limit as x approaches infinity of g of x equals 5, meaning as x gets closer to infinity, y gets closer to 5. And if that sounds a lot like end behavior, that's exactly what it is. You can also talk about the left side, so as x gets closer to negative infinity, y gets closer to 5. So that could happen, for example, if you have an equation with a horizontal asymptote at y equals 5. As x gets closer to infinity, the y will get closer to 5. And as x gets closer to negative infinity, the y will also get closer to 5. Alright, in 13, we're looking at a graph again. We want the limit of g of x as x approaches positive infinity. So it seems to be leveling out here at an asymptote. I'm going to say that this asymptote is at y equals 2. So we're going to say that this limit is 2. The limit as x goes to negative infinity. So this is on this side. This one also seems to be leveling out at an asymptote, and that asymptote seems to be down here at negative 2. So I'll call that one negative 2. And I'll switch color. The limit as x approaches 3, so here's 3. And you can see on the left and on the right, they both seem to be going to infinity, so that will be my answer. And the limit as x approaches 0, well, that seems to be a number right about here. We can estimate that number to be about negative 0.8. And the limit of g of x as x approaches 2 from the right. So here's 2 approaching 2 from the right. We seem to be lower than 1, so I might guess 0.7 estimate. Let's see. I'm going to go back to D for a minute because I think I was reading the number at 1. So the number at 1 was about 0.8, but the number at 0 is actually going to negative infinity. So as x approaches 0, y is going to negative infinity on both sides. Alright, and the last question says, what are the asymptotes? So you can see that you have vertical asymptotes here and here and also here. So the vertical asymptotes are going to be at x equals negative 2, x equals 0, and x equals 3. And you have horizontal asymptotes at y equals, let's see again, 1, 2, y equals negative 2, and at y equals positive 2. Alright, now we're going to be finding asymptotes. So, vertical asymptotes make your denominator 0. So for those I like to factor. I have x plus 5 times x minus 2. So that tells me I have vertical asymptotes at x equals negative 5 and x equals 2. Alright, for the horizontal asymptote, I'm looking at the degree of the numerator and the degree of the denominator. And since the numerator has a greater degree, this actually has a slant asymptote, so it has no horizontal asymptote. Okay, in B, I'm looking at my denominator again. I'm going to factor out x, and then I have x times x squared plus 1. So if I set them both equal to 0, x squared plus 1 gives me imaginary numbers. So I'm going to stick with this one, x. I get x equals 0. So I have a vertical asymptote at x equals 0. And then my horizontal asymptote comes from the degree here is 3 and the degree here is 3, and since they're the same, you want the lead coefficients of each term, 1 over 1. So my horizontal asymptote is y equals 1. Okay, in the next section we're looking for the end behavior. So you're looking for the term with the largest degree in the numerator and denominator. So here the degrees are the same, meaning we're going to have a horizontal asymptote, and that horizontal asymptote will be your end behavior. So x squared over x squared, and then negative 3 over 4. So if this is negative 1, I can do it negative 3/4, my horizontal asymptote, meaning that will be my end behavior. So as x goes to infinity, y goes to negative 3/4. In the denominator, I'm hoping that I have a whole, so I'm going to factor, and I have x plus 2, x plus 3, so those cancel, giving me just 1 over x plus 3. And if I substitute in negative 3, well, again, this is going to be undefined. So let's see if our branches go one direction or the other. 1, 2, 3, I need my asymptotes. And this is just the parent function 1 over x shifted right 3. So I happen to know my branches go here and here, which means one's going to infinity and one to negative infinity, so this limit does not exist. The limit as n goes to infinity for 34, well, that means this function is always at 34. So as n goes to infinity, your y value will still be 34. Alright, in D, I need to figure out, well, let's see, my denominator's already factored, so that means I have vertical asymptotes at x equals 5 and x equals 1, but this is asking the limits, so I don't care about the vertical asymptotes. What I care about is the degree. So this is going to give me a biggest term of x squared, and this gives me a biggest term of x, which overall is x cubed. So x cubed over x cubed is going to give me a horizontal asymptote at y equals 1. So that's also going to be my end behavior, so my limit will be 1. Alright, biggest degree divided by biggest degree, negative x squared over x gives me negative x. So that means my end behavior is a slant asymptote. And because the slope is negative, it's going to be going up on the left. So as x goes to negative infinity, the y is going to be going to positive infinity. Alright, and in 4 we need to multiply by the conjugate of root x minus 2, so I multiply by root x plus 2. Root x plus 2. In the denominator, square root x times square root of x is x. Middle terms cancel out, and negative 2 times 2 is negative 4. And in the numerator, I leave it factored. So my x minus 4's can cancel out, and now I can substitute 4 back in. So I have the square root of 4 plus 2, which is 2 plus 2, which is 4. Okay, let's turn the page and finish this up. Alright, on the next page, again, we're looking for the end behavior. So when you look at the end behavior, you're just looking at the largest degree. So in the numerator, I have 1x squared, and in the denominator, I have 2x squared. And when I divide them, I get 1/2. Meaning I have a horizontal asymptote at y equals 1/2, and that also is the end behavior. In h, I have 2x squared over 5x to the 4th, which gives me 2/5 x to the negative 2. So this is telling me, oh yeah, the denominator had a bigger degree, which means that I had a horizontal asymptote at y equals 0. And since I have that horizontal asymptote, that's also my end behavior. So this answer is going to be 0. In I, I'm going to divide negative x squared by x. I get negative x, which is a line with a downward slope. So as x goes to positive infinity, the y is going down to negative infinity. Alright, here's another constant function. the y is always 9. So as x approaches 3, your y is going to be 9. The next one, I need the largest degree again. So the largest degree here is x, and the largest degree here is x squared. That gives me x cubed. So now I can see that I have a bigger degree in the denominator, which means I have a horizontal asymptote at y equals 0. So my limit as x approaches negative infinity is 0. And in L, if I were to substitute in directly, I should get 0 over 0. So instead, I need to simplify first. So I'm going to get a common denominator by multiplying the first fraction by x over x and the second by 5 over 5. And I get 4x minus 20 over 5x over x minus 5. And I can factor this to be 4 times x minus 5 over 5x over x minus 5. So now the x minus 5's cancel out, and I have just 4 over 5x. So as x approaches 5, you plug that in, and you get 4 over 5 times 5, which is 25. Okay. Alright, the limit as x approaches 6 from the right, and this is going to be x over x minus 6. So this is not exactly a transformation of the parent function. Let's see what's happening on the right of this function. If I were to plug in 6.5, let's see what we get. I would get 6.5 over 6.5 minus 6, which is 0.5. So anything divided by half is double it, so this would be 13. So that's 13. And if I go to 7, I'm going to get 7 over 7 minus 6, which is 1. So that's 7. Alright, so these values seem to be getting lower. But what we're doing is we're actually supposed to be approaching 6. So we're starting at 7, and then we go to 13. So it looks like as x approaches 6, y values are going to positive infinity. And then in n, I'm going to multiply these out to get x squared minus 4x plus 3. And now I have x squared over x squared, so I know there's a horizontal asymptote at 1 over 1. So my n behavior should be 1. However, this question is not asking about the n behavior, it's asking about the behavior as x approaches 3 from the left. So I'm going to erase this where I multiplied it out because I only need that for the n behavior. And I see that if I just plugged 3 in, I would get a 0 in my denominator, which is trouble. So approaching 3 from the left, I'm going to just choose a number like, for example, 2. If I plug in 2, I get 2 squared, which is 4, and 2 minus 3 is negative 1, and 2 minus 1 is positive 1, so I get negative 4, which looks like it's going to negative infinity. And you can try other values as well to verify this, but this answer is going to be negative infinity. Alright, so make sure that in addition to completing this review, you also make corrections in ink to your review packet. You correct all of your quizzes, make up any missing homework, and of course you can always look in the online textbook for more help.